All right, let's do 2.4 notes, absolute value functions. With our absolute value functions, we want to get some basic idea about what absolute value is. So that's going to be your distance from 0. So for instance, if I have y is equal to the absolute value of 4, that's going to be 4, right? If I have y is equal to the absolute value of negative 4, then I'm going to have this still as 4. Because whether I'm talking about 4 or negative 4, the distance from 0 is still the same, right? It's still a value of 4 away from there. So anytime you have that absolute value, it's always going to equal a positive number. Because it is the distance from 0. Okay, so if I go and I want to try to graph that, all right? So let's look at these graphs here. I'm going to graph here at 1a, y is equal to a 2x minus 1. Because I'm just going to look at the line. And if you think back to when we were talking about our absolute value in that last section, then you remember with your absolute value, it can't be negative, so it looks like a V. So now we're going to look at this, what it looks like as a line, and then again, what it looks like as an absolute value to try to make those comparisons is what's happening here. Okay, I'm going to put it on this grid to try to make it more accurate. So the first thing that I'm going to graph here is this y is equal to 2x minus 1. I know my slope is 2 over 1, and my y-intercept is 0, negative 1. So I'm going to start down here at negative 1. I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. Down 2, back 1. And draw that. So that's my line, right, that we have. But when you take the absolute value, it affects the line and it adjusts it that I have. So I'm not looking at all of the exact same values here. Then we're adjusting this in order to pull this off. So when I make the adjustment for my absolute value here, it adjusts the graph because I can't have those negative parts. So if I'm going to do this one, then we're going to say, we're just going to do a T-chart here just to make it a little bit easier. If I were to plug a 0 into this, so that is 0, the absolute value of negative 1 is 1. That's going to be where my vertex is. When x is 0, y is 1. When x, if we keep going in the other direction, like let's say x is negative 1 here, so just in your head, you know that this is negative 2 minus 1. The absolute value of negative 3 is going to be 3. If I go the other direction with it on the 1, do the same kind of thing. If I plug a 1 in here, 2 times 1 is 2 minus 1 is 1. So now I have the point 0, so I have the point over 0 up 1. I have the point over 1 up 1. Oh, dang it. I moved it. Let me get off of that. And I have the point negative 1 up 3. And I bet if I go one more over here with this 2, if I'm going to plug in a 2 right here, oh, dang it. I've got a 4. 2 times 2 is 4 minus 1 also gives me 3. So do you see what's happening here? Now, if I want to know when x is on my y is 0 here, then I can set this equal to 0, and that's going to give me that intercept. But do you see what's happening? It's going to be at this 1/2. So you've got that 2x minus 1 equals 0. So if I solve this, x is a 1/2. So I have the point here of 1/2 and 0. Do you see what happened? So it's the same line, and where that line hits that x-axis, then it starts jumping back up because it can't be negative. So I thought maybe looking at it in terms of points would be helpful, so you can see how they line up, just so that you know what's happening there. So that's absolute value. It's okay, it's just like the regular line all the way down to that x-axis. Then it can't have negative y outputs, so then we jump it back up. And it's going, the same line that would be going down here is now going up here in this direction to make that positive. So that's just the graphs. I really honestly just want you to have some basic working knowledge of the graphs. So I think in my math lab, it's multiple choice or something like that, or matching. So you'll be able to get that off. But I just wanted you to have that basic. So it's nice sometimes to have that visual representation of what it looks like. Okay, so let's solve a couple. Here's example 4. The fact that I can have, so the absolute value of 2x plus 1 is equal to 7. The fact that this is both going to be, and the insides of it can be both positive and negative. Whenever I do that, I have to account for both of those. So when you solve absolute value, you're going to take these guts, because my inside guts here, once I do all my working, that could be a 7, because the absolute value of 7 is 7. I can also have the absolute value of negative 7, right? The absolute value of negative 7 will also be 7. So what I'm really trying to figure out is the guts of my absolute value. What value of x is going to make that a positive 7 and a negative 7? So when you do this, you drop those absolute values and you set those up to be both a positive and negative 7. So solve each one. Here I'm going to subtract 1 from both sides. I've got 2x equals 6. Divide by 2, x is equal to 3. Same thing, subtract 1 from both sides. I've got 2x is equal to a negative 8. And x is now equal to negative 4. These are not going to be plus or minus of each other, right? That's just going to be these two separate values. So over on my other one, where it's a 2x plus 1 actually, but if you look at the graph, I'm going to scoot back over here. What I want to know, let's say I want to know when x is, what value of x whenever I have my output is equal to 3, right? So here is 3. So this, if I were to solve the equation, the absolute value of 2x minus 1 is equal to 3, what two answers are we going to have? Negative 1 and positive 2. Because that is when y is equal to 3, that is where it hits on my graph. That's what's happening here. Of the graph, y is equal to the absolute value of 2x plus 1. If I want to say what are the values, if I were to have that constant at 7, then this is those x values where it would hit that. That's what we're doing for absolute value function. That's why you have to do both positive and negative, because it makes that v, and then you go with that. Okay.